Hello everyone, and welcome back to our SecurityX course. In this lesson, we'll explore common vulnerabilities and attacks, including injection attacks, cross-site scripting, race conditions, and more. We'll also delve into effective mitigation techniques, such as input validation, output encoding, adopting security design patterns, and more. Injection attacks. Injection attacks occur when untrusted input is sent to an interpreter as part of a command or query. SQL injection is one of the most common forms, where attackers manipulate SQL queries to access unauthorized data. Command injection, LDAP injection, and XML injection are other examples. These attacks can result in data breaches, privilege escalation, or system compromise. Cross-site scripting. Cross-site scripting involves injecting malicious scripts into trusted websites or applications. These scripts run in the browser of unsuspecting users, potentially stealing sensitive information like session cookies or redirecting users to malicious sites. Race conditions. Race conditions arise when multiple processes or threads access shared resources simultaneously, leading to unexpected behavior. Attackers exploit race conditions to gain unauthorized access, escalate privileges, or manipulate data. For example, an attacker might exploit a race condition in a payment system to execute duplicate transactions. Cross-site request forgery. Cross-site request forgery tricks users into performing unwanted actions on a website where they are authenticated. For example, a CSRF attack might trick a user into changing their account password or transferring funds without their knowledge. Server-side request forgery. Server-side request forgery involves tricking a server into making unauthorized requests to internal or external systems. Attackers can use SSRF to scan internal networks, access sensitive information, or exploit vulnerable services that are not exposed to the public internet. To address these vulnerabilities and reduce the attack surface, it's essential to implement effective mitigation strategies. Input validation. Input validation ensures that all input data is verified and sanitized before being processed by an application. By validating input, you can prevent injection attacks, buffer overflows, and other vulnerabilities caused by untrusted or malformed data. For example, SQL queries should validate input to ensure it does not contain malicious commands. Output encoding. Output encoding converts special characters in output data to a safe format, preventing them from being interpreted as executable code. This is particularly effective against XSS attacks, as it ensures that user-generated content displayed in a browser is treated as text rather than executable script. Safe functions. Using safe functions and secure libraries reduces the risk of vulnerabilities in application code. For example, prepared statements and parameterized queries in SQL can prevent SQL injection by separating data from executable commands. Security design patterns. Security design patterns are established solutions to common security challenges. For instance, the principle of least privilege ensures that users and processes have only the permissions they need, reducing the risk of privilege escalation. Another example is input sanitization, which incorporates secure practices into the design phase of application development. In summary, analyzing vulnerabilities and attacks is a fundamental step in building a secure IT environment. Thank you for joining us today, and see you soon.